Hello students, today we will start chapter number 7 of NCERT, that is integrals. Now what are integrals? Suppose there is a function y and we differentiate it with respect to x, then its derivative will be dy by dx. Or there is a function fx, then its derivative will be f dash x. Now suppose the derivative is given to us, that means dy by dx is given to us and we have to find the function. Then we will find out the antiderivative of dy by dx. Antiderivative of dy by dx, or f dash x is given to us and we have to find the function. Then we will find antiderivative of f dash x, and that will be fx. Now this antiderivative is called the integral, or therefore we can say that integral of dy by dx will be equal to y and integral of f dash x will be equal to fx. Now the integral of function fx is represented by integration of fx dx plus c. Now here c is the constant which is added to a integral of a function. Now here are integrals of some functions which you have to remember. Now integral of 1. Now as we know that derivative of x, that d by dx of x is equal to 1. So integral of 1 will be equal to x plus c. Now derivative of cos x is equal to minus sin x. So integral of sin x will be equal to minus cos x plus c. Here derivative of sin x is equal to cos x. So integral of cos x will be equal to sin x plus c. Now integral of sec x will be equal to log sec x plus tan x plus c. Integral of cosec x will be equal to log cosec x minus cot x plus c. Now integral of e raised power x, now derivative of e raised power x is equal to e raised power x. So integral of e raised power x will be equal to e raised power x plus c. Derivative of a raised power x is equal to a raised power x log a. So from here we can say that 1 upon log a into d by dx of a raised power x will be equal to a raised power x on dividing both sides by log a. So we can say that integral of a raised power x will be equal to 1 upon log a into a raised power x. Now derivative of tan x is sec square x. So integral of sec square x will be equal to tan x plus c. Here integral of cot x is equal to minus cosec square x. Sorry, derivative of cot x is equal to minus cosec square x. So integral of cosec square x will be equal to minus cot x plus c. Now here integral of x raised to power n is equal to x raised to power n plus 1 upon n plus 1 plus c. Integral of sec x tan x is equal to sec x plus c, as derivative of sec x is sec x tan x. Now here integral of cosec x cot x. Now in derivative of cot x, cosec x is equal to minus cosec x cot x. So the integral of cosec x cot x will be equal to minus cosec x plus c. Now come to exercise 7.1. We have in question number first we have to find out integral of sine 2x. As we know that d by dx of cos 2x or derivative of cos 2x is minus 2 sine 2x. Now on dividing both sides by minus 2, we can say that sine 2x will be equal to minus 1 upon 2 d by dx of cos 2x. That means integration of sine 2x will be equal to minus 1 upon 2 cos 2x plus c. Now in question number third, we have to find out integral of e raised to power 2x dx. Now as we know that d by dx of e raised to power 2x is equal to 2 e raised to power 2x. So e raised to power 2x will be equal to 1 by 2 d by dx of e raised to power 2x. Or we can say therefore e raised to power 2x will be equal to d by dx of 1 upon 2 e raised to power 2x. Or we can say integral of e raised to power 2x dx will be equal to 1 by 2 e raised to power 2x plus c. On question number 5th, we have to find out integral of sine 2x minus 4 e raised to power 3x. Now this can be written as integral of sine 2x dx minus 4 into integral of e raised to power 3x dx. Now here, first of all, we have to find out the integral of sine 2x. As we know, d by dx of cos 2x is equal to minus 2 sine 2x. So sine 2x will be equal to minus 1 by 2 d by dx of cos 2x or d by dx of minus 1 by 2 cos 2x. That means integral of sine 2x dx will be equal to minus 1 by 2 cos 2x plus c. Now here there are two functions, so I am taking first constant at as c1. Similarly, now we will find out the integral of e raised to power 3x. Now d by dx of e raised to power 3x is equal to 3 e raised to power 3x. So e raised to power 3x will be equal to 1 by 3 d by dx of e raised to power 3x. Now that means e raised to power 3x will be d by dx of 1 by 3 e raised to power 3x, and this will give us integral of e raised to power 3x will be equal to 1 by 3 e raised to power 3x plus c2. That means that integral of sine 2x minus 4e raised to power 3x dx will be equal to, now integral of sine 2x was minus 1 upon 2 cos 2x, and integral of 4 into e raised to power 3x will be 4 into 1 by 3 e raised to power 3x, and c1 plus 4 c2 can be written as equal to c. That means our answer will be minus 1 by 2 cos 2x minus 4 upon 3 e raised to power 3x plus c. Now in question number 10, we have to find the integral of root x minus 1 upon root x whole square. Now here we can apply the formula of a minus b whole square, and that will give us integral of x plus 1 upon x minus 2 dx. Now these can be written separately as integral of x dx plus integral of 1 upon x dx minus 2 into integral of 1 dx. Now as we know, integral of x raised to power n dx equal to x raised to power n plus 1 upon n plus 1 plus c. So integral of x raised to power n will be equal to x raised to power 1 plus 1 upon 1 plus 1, and that will be x square upon 2. Now d by dx of 1 upon d by dx of log x is equal to 1 by x. So integral of 1 upon x will be equal to log x minus 2. Now derivative of x is equal to 1. So integral of 1 will be equal to x, and c is constant of integral here. And question number 12, we have to find integral of x square plus 3x plus 4 upon root x dx. Now on dividing all the terms separately by root x, we will get it as integral of x 2 minus 1 by 2 plus 3 into integral of x 1 minus 1 by 2 plus 4 on root x, or 4x raised to power 1 by 2. Now that will be x raised to power 3 by 2 plus 3 x raised to power 1 by 2 plus 4 x raised to power minus 1 by 2 dx. Again, d by dx of x raised to power n is equal to x raised to power n plus 1 upon n plus 1. So integral of x raised to power 3 by 2 will be equal to x raised to power 3 by 2 plus 1 upon 3 by 2 plus 1 plus 3 into x raised to power integral of x raised to power 1 by 2 will be x raised to power 1 by 2 plus 1 upon 1 by 2 plus 1, and integral of x raised to power minus 1 by 2 will be equal to x raised to power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. Now this will give us the integral as 2 by 5 x raised to power 5 by 2 plus 6 by 3 x raised to power 3 by 2 plus 8 x raised to power 1 by 2 plus c. Now this 6 by 3 can be written as 2. And question number 18, we have to find out the integral of sec x into sec x plus 10x dx. Now on multiplying it, we will get it as integral of sec square x plus sec x 10x. Now integral of sec square x is 10x, and integral of sec x 10x is equal to sec x. So its integral will be 10x plus sec x plus c. In question number 19, integral of sec square x upon cosec square x dx can be written as, now sec square x can be written as 1 upon cos square x, and cosec square x can be written as 1 upon sin square x. Now this will give us integral of sin square x upon cos square x dx, and that will be equal to integral of 10 square x. Now we know that 1 plus 10 square x is equal to sec square x. So this 10 square x can be written as sec square x minus 1. Now as integral of sec square x will be equal to 10x, and integral of 1 is equal to x plus c, as derivative of 10x is sec square x and derivative of x is 1. Now integral of 10 square x dx is, now if we want to find the integral of 10 square x, then we will convert it into sec square x minus 1, and if we want to find out the derivative of cot square x, then we will convert it into cosec square x minus 1 dx by using the identity 1 plus cot square x equal to cosec square x. And question number 20, integral of 2 minus 3 sin x upon cos square x dx can be done by dividing 2 and 3 sin x separately by cos square x. Now 2 upon cos square x will be 2 into sec square x, as sec is reciprocal of cos. Now 3 sin x upon cos square x can be written as 3 sin x upon cos x into 1 upon cos x. Now 3 into sin x upon cos x will be equal to 10x, and 1 upon cos x will be equal to sec x. Now this will be equal to 2 into integral of sec square x dx minus 3 into integral of sec x 10x dx. Now as we know, derivative of 10x is equal to sec square x. So integral of sec square x will be equal to 2 10x will be equal to 10x, and derivative of sec x is equal to sec x 10x. So integral of sec x 10x will be equal to sec x, and c is the constant of integral here. In question number 22, if d by dx of fx is equal to 4x cube minus 3 upon x to the power 4 such that f2 is equal to 0, then we have to find out the value of fx. Now here d by dx of fx is given to us. So integral of d by dx of fx dx will be equal to integral of 4x cube minus 3 upon x to the power 4 dx on integrating both sides. Now integral of d by dx of fx will be equal to fx, and that will be equal to 4 into integral of x cube minus 3 into integral of 1 upon x to the power 4, and that can be written as x raised to power minus 4 dx. Now by using the formula integral of x raised to power n dx equal to x raised to power n plus 1 upon n plus 1, we can say that integral of x cube will be equal to x to the power 4 upon 4, and integral of x raised to power minus 4 will be equal to x raised to power minus 4 plus 1 upon minus 4 plus 1, and that will be x raised to power minus 3 upon minus 3 plus c. Now this will give us fx as x to the power 4 now plus 1 upon x cube plus c. Now here it is also given to us that f2 is equal to 0. So we can say that f2 that is equal to 2 raised to power 4 plus 1 upon 2 cube plus c will be equal to 0. Now this implies that 16 plus 1 by 8 plus c will be equal to 0, and this will give us the value of c as minus 129 by 8. Thus we can say that fx will be equal to x to the power 4 plus 1 upon x cube plus c, and c was minus 129 by 8. Now come to exercise 7.2. Now in exercise 7.2 we will check whether the derivative of a part of function is present in the question or not. If the derivative of a part of the function is present in the question, then we will take it as another variable to solve it. Now here we have to find the integral of 2x upon 1 plus x square. Now as we know that derivative of 1 plus x square will be equal to 2x, and this is present in the question itself. So we will take 1 plus x square as another variable. Here I am taking 1 plus x square as t. Now on differentiating both sides with respect to t, now d by dt of 1 plus x square will be equal to d by dt of t. Now this will give us d by dt of 1 will be 0, and d by dt of x square will be equal to 2x dx by dt, and that will be equal to d by dt of t will be equal to 1. Now we can take this dt to the other side, and that will give us 2x dx equal to dt. So we can, if 1 plus x square is equal to t, then 2x dx will be equal to dt. Now here I will be equal to, now here 2x dx is coming as equal to dt. So in place of 2x dx we will write down dt, and 1 plus x square was taken as t, so I can be written as 1 upon t, and 2x dx was equal to dt, to 1 upon t dt. Now the derivative of log t is 1 upon t, so integral of 1 upon t will be equal to log t plus c. Now value of t was 1 plus x square, so this can be written as log 1 plus x square plus c. In question number 3rd, now it is similar to question number 1st. Now here we have to find the integral of 1 upon x plus x log x dx. Now in the denominator we can take x as common, and this will give us I as 1 upon x 1 plus log x dx. Now as we know that d by dx of 1 plus log x will be 1 upon x, and here 1 upon x is present in the question, so we will take 1 plus log x as t. Now on taking 1 plus log x as t, now derivative of 1 will be 0 and derivative of log x will be 1 upon x dx, and that will be equal to dt. Now on putting these values in first, we are getting I as, now here 1 upon x dx was equal to dt and 1 plus log x of t, so I will be equal to 1 upon t dt. As we know, integral of 1 upon t will be equal to log t plus c, and that will give us, on putting the value of t, I will be equal to log 1 plus log x plus c. Now in question number 4th, now I is equal to integral of sin x cos x dx. Now here cos, as we know, the d by dx of sin x is equal to cos x, and d by dx of cos x is equal to minus sin x. But here this cos is a function of sin, so we will take this cos x as t. Now if we take cos x as t, then d by dx of cos x will be minus sin x dx. Derivative of cos x will be minus sin x dx, and derivative of t will be dt. And this will give us sin x dx equal to minus dt. Now, so in place of sin x dx, we will take minus dt, and sin cos x will be equal to sin t, as cos x we have taken as t, and this will be equal to minus integral of sin t dt, on taking minus 1 outside the integral, as it is constant. As we know, derivative of cos x is equal to minus sin x, so derivative integral of sin t will be equal to minus cos t, and that will give us I as cos t plus c. Here t was equal to cos x, so integral will be cos of cos x plus c. Now in question number 7th, we have to find integral of x under root x plus 2. Here also, now if we take this x plus 2 as t, then dx will be equal to dt. Now derivative of x will be 1 and 2 will be 0. That will 1 dx will be equal to dt. Now here in place of root x plus 2, we can take root t, and as here we are changing the variable from x to t, so this x, we will change this x, or we will write this x in terms of t. Now as we have taken x plus 2 equal to t, so x can be written as t minus 2. So in place of x we will take t minus 2, and root x plus 2 was t and x plus 2 was t, so it will be root t, and dx is equal to dt. So in place of dx we will take dt. Now we can multiply these terms separately by root t to give us t raised to power 3 by 2 minus 2 into t raised to power 1 by 2 dt. Then we can integrate them separately by using the formula integral of x raised to power n dx, that equal to x raised to power n plus 1 upon n plus 1 plus c. And then we will put the value of t, that was x plus 2, and the value of integral will be equal to 2 upon 5 x plus 2 raised to power 5 by 2 minus 4 upon 3 x plus 2 raised to power 3 by 2 plus c. Now in question number 10th, I is equal to integral of 1 upon x minus root x. Now here we can take root x common from x minus root x, and this will give us integral as 1 upon root x into root x minus 1. Now as in derivative of root x minus 1 is equal to 1 upon 2 root x dx, so we will take root x minus 1 as t, and this will give us derivative on differentiating both sides. This will give us 1 upon 2 root x dx equal to dt. or we can say 1 upon root x dx equal to 2 dt. Now here 1 upon root x dx can be written as dt. 1 upon root x dx is equal to 2 dt. So this will give us I equal to 1 upon t, as root x minus 1 was taken as t into 2 dt. Now we can take 2 as common, or 2 outside the integral. It is a constant term, so this will I will be equal to 2 into integral of 1 upon t dt, and integral of 1 upon t will be equal to log t, as d by dt of log t will be equal to 1 upon t. And on putting the value of t, we will get the integral as 2 log under root x minus 1 plus c. In question number 12, here if we take x cube minus 1 as t, then we are getting 3x squared dx as dt, or we can say x squared dx equal to dt by 3. But here x to the power 5 is given to us and we need x square. So we can write this x to the power 4 as a multiple of x square and x cube. Now on taking x cube minus 1 as t, we will get x squared dx as dt by 3, and this will give us I as, now here x cube minus 1 was taken as t, so this will be t raised to power 1 by 3. Now x square dx can be written as dt by 3, and this x cube will be equal to t plus 1. So this will give us the integral as 1 by 3 integral of t raised to power 1 by 3 into t, that will be t raised to power 4 by 3 plus t raised to power 1 by 3 into 1, that will be t raised to power 1 by 3 dt. Now this can be solved by using the formula integral of t raised to power 4 by t raised to power n will be equal to t raised to power n plus 1 upon n plus 1, which is giving us the answer as, after putting the value of t as 1 by 7 x raised to power x cube minus 1 raised to power 7 by 3 plus 1 upon 4 x cube minus 1 raised to power 4 by 3 plus c. Now in question number 19, we have to find the integral of e raised to power 2x minus 1 upon e raised to power 2x plus 1 dx. Now, on dividing the numerator and denominator by e raised to power x, we get I as e raised to power 2x minus 1 upon e raised to power x, e raised to power 2x plus 1 upon e raised to power 2x, e raised to power x. And this will be, on dividing both the terms separately, this will be equal to e raised to power x minus 1 upon e raised to power x, and that can be written as e raised to power minus x whole upon e raised to power 2x upon e raised to power x, and that will be e raised to power x plus 1 upon e raised to power x, and that can be written as e raised to power minus x. Now, on taking e raised to power x plus e raised to power minus x as t, to e raised to power x minus e raised to power minus x dx will be equal to dt. And this will give us I as integral of, now this whole was equal to dt, so this will be equal to 1 upon t dt, which, now integral of 1 upon t dt will be equal to log t plus c. Now we can put the value of t, that was e raised to power x plus e raised to power minus x, so I will be equal to log e raised to power x plus e raised to power minus x plus c. Now in question number 25, I is equal to integral of 1 upon cos square x into 1 minus tan x whole square dx. As we know, derivative of tan x is equal to sec square x, and 1 upon cos square x can be written as sec square x. So here we will take 1 plus tan x as t, and on taking 1 minus 10x xt minus sec square x dx will be equal to dt. So I will be equal to minus 1 upon this sec square x dx will be equal to minus dt. So this will be equal to 1 upon minus 1 upon t square dt, which can be written as minus integral of t raised to power minus 2 dt, and which on solving will give us the integral as 1 upon t plus c, and on putting the value of t, I will be equal to 1 upon 1 minus 10x plus c. Now come to question number 32. Here we have to find the integral of 1 upon 1 plus cot x dx. Now I have taken it as I. Cot x can be written as cos x upon sin x, and on taking LCM we can write the integral as 1 upon sin x plus cos x upon sin x, which can be written as sin x upon sin x plus cos x. Now here denominator is sin x plus cos x, and d by dx of sin x plus cos x is cos x minus sin x. Here if you see the numerator sin x is positive, so it can be written as minus sin x minus cos x, on taking minus 1 as common. Now if we convert this numerator into the derivative of sin x plus cos x, then we can write the numerator as sin x minus cos x, so that it becomes the derivative of sin x plus cos x. Now here we have to eliminate this cos x, so we will add cos x to it so that the question doesn't change. But here if we integrate these separately, we will get sin x minus cos x upon sin x plus cos x dx, and plus integral of this, here it was plus cos x upon sin x plus cos x. Now this cos x is again creating a problem. If we write in place of cos x, if we take it as sin x, so this will simplify our problem, and sin x plus cos x upon sin x plus cos x will be equal to 1. So here we will add sin x to it so that it becomes equal to the denominator sin x. Now this part is the derivative of the denominator, and this part is equal to the denominator. But here as we see, now cos x will be eliminated. Now sin x plus sin x will be equal to 2 sin x. So this sin x can be converted into 2 sin x, and this 2 can be eliminated by dividing the equation by 2. So this will give us 1 by 2 integral of sin x minus cos x plus sin x plus cos x dx upon sin x plus cos x, and that will be equal to 1 by 2 sin x minus cos x upon sin x plus cos x, and sin x plus cos x upon sin x plus cos x. Now sin x plus cos x upon sin x plus cos x will be equal to 1. Now on taking sin x plus cos x as t in the first part, and on differentiating it, we are getting its derivative as cos x minus sin x dx equal to dt. Now this can be written as sin x minus cos x dx equal to minus dt on multiplying both sides by minus 1. So our integral will become 1 upon 2 integral of, now sin x minus cos x dx was equal to minus dt, to minus dt upon t, as sin x plus cos x was equal to t, plus 1 by 2, and derivative integral of 1 will be equal to x plus c1. Now we can take minus 1 outside the integral, it is constant, so this will be equal to minus 1 upon 2, and 1 by t, integral of 1 by t will be equal to log t plus 1 by 2x plus c. Now on putting the value of t, we will get the integral as minus 1 upon 2 log sin x plus cos x plus 1 by 2 x plus c. Similarly, we can solve the integral of 1 plus 10x dx. Here also we will add 2 cos. Now here we will convert this 10x into cos x sin x upon cos x, and which on taking LCM will give us cos x upon cos x plus sin x. Now here also derivative of cos x plus sin x will be minus sin x plus cos x. So we will divide and multiply the integral by 2, and then we can write this as 2 cos x as cos x minus sin x plus cos x plus sin x upon cos x plus sin x dx, and then this can be solved as we have solved question number 32. Now come to question number 34. Here I is equal to under root integral of under root 10x upon sin x cos x dx. Now on dividing the denominator by cos x, dividing and multiply the denominator by cos x, this will be root 10x upon sin x upon cos x will be equal to 10x, and cos x into cos x will be cos square x. Now 1 upon cos square x can be written as sec square x, and root 10x upon 10x will be equal to root 10x, 1 upon root 10x. Now here, as we know, derivative of 10x is sec square x, so we will take 10x as t to give us sec square x dx as dt, and so our integral will be equal to integral of 1 upon root t dt as sec square x dx was equal to dt, and this can be written 1 upon root t can be written as t raised to power minus 1 by 2, and t raised to power integral of t raised to power minus 1 upon 2 will be 2 root t plus c, and on putting the value of t we will get the integral as 2 root 10x plus c. In question number 36, I is equal to integral of x plus 1 into x plus log x whole square upon x dx. As we know, the integral of derivative of x plus log x will be equal to 1 plus 1 upon x dx dt. So here we will divide x plus 1 by x. So this will give us integral of x plus 1 upon x into x plus log x whole square dx. Now on dividing x plus 1 separately by x, both x and 1 separately by x, we are getting this as integral of 1 plus 1 upon x into x plus log x whole square. Now this 1 upon 1 plus x is derivative of x plus log x, so we will take x plus log x as t, and its derivative will be 1 plus 1 upon x dx equal to dt, and our integral will become, now this 1 plus 1 upon x dx will be equal to dt, and we have taken x plus log x as t, so integral will be t square dt, and which can be solved to give us the value of integral as 1 by 3 x plus log x whole cube plus c. Now in question number 37, here I is equal to integral of x cube sine tan inverse x to the power 4 upon 1 plus x to the power 8. Now here, this is x to the power, now x to the derivative of x to the power 4 is 4x cube, and we have x cube in the question, so we will take x to the power 4 as t, and this will give us 4x cube dx as dt, or we can say x cube dx will be equal to dt by 4. Now this, so our integral will become sine tan inverse t upon 1 plus t square dt by 4, as x cube dx was this x cube dx was dt by 4, and here 1 plus x to the power 8 can be written as 1 plus x to the power 4 whole square, and this will be 1 plus t square. So denominator will become 1 plus t square. Now this will be 1 by 4 sine tan inverse t 1 plus t square dt. Now here derivative of tan inverse t will be 1 plus t square. So we will take tan inverse t as u, and on differentiating both sides we will get 1 upon 1 plus t square dt equal to du. Now this 1 upon 1 plus t square dt will be equal to du, and thus our integral will be 1 upon 4 sine t dt. Sine u du. Now we can integrate sine u, and integration of sine u will be equal to minus cos u, and this will give us integral as minus 4 cos u plus c. Now we have taken tan inverse t as u, so the integral will be minus 1 upon 4 cos tan inverse t plus c. Now t was again taken as x to the power 4, so this will give the integral as minus 1 upon 4 cos tan inverse x to the power 4 plus c. Now in question number 38 we will take the denominator, that is x raised to power 10 plus 10 raised to power x as t, as its derivative is 10 raised to power 10 x raised to power 9 plus 10 raised to power x log 10. In question number 39, I is equal to dx upon sine square x plus cos square x. Now this one can be written as sine square x plus cos square x. Now on dividing these separately, we will get it as sine square x upon sine square x plus cos square x upon sine square x cos square x. Now here sine square x will cancel out, and cos square x will cancel out to give us integral as 1 upon cos square x plus 1 upon sine square x. Now 1 upon cos square x is equal to sec square x, and 1 upon sine square x will be equal to cosec square x. Now integral of sec square x will be equal to 10x, and integral of cosec square x will be equal to minus cot x plus c. Thank you.